Okay, just remember to press record. Sorry for the, whatever you see on the screen. Okay, the purpose of today's webinar is to, as far as possible, very highly compressed training on the use and the functions of our StarLab software application. Just before we begin, on a logistical note, first of all, the total length of today's webinar will be approximately 45 minutes, plus or minus. Very important, I ask all of you who have microphones input to please make sure that you are muted as a courtesy to all other participants in the webinar. I do have a little button here called Mute All. Please make sure that you are muted. Anybody of you with a webcam on, please make sure your webcam is off. Okay. Those of you with microphones, remain muted. Those with webcams, please turn off your webcams. As a courtesy to all their participants in the webinar. The purpose of today's webinar, as I said, is to give a quick training in the use of StarLab. I must stress, and I'll mention this again during the course of the webinar, there's no way within the scope of a 45-minute webinar to really go in depth. When we host training here for new leaders, for example, here at the Ophir facility in Jerusalem, we typically allocate about 6 hours for hands-on work with the equipment, and about 3 hours out of that is spent working with StarLab. So in the space of a 45-minute webinar, we can't really do what one would do in a real training. For those of you who are new on the team, this will hopefully bring you up to speed reasonably quickly, so that you'll have a reasonable comfort level with the use of StarLab. And those of you who are more experienced, I hope that this will serve as a valuable refresher of some kind. Questions are and even encouraged. If you have questions, please ask them using the text chat box on the right side of your screen. I will do my best to answer your questions either in real time or at a suitable point in the flow of the information, depending on the name and the timing of the questions. I'm speaking too fast for anybody. Please send me a text message using that chat box. What I type in the chat box is seen only at this end, so you can feel free to make use of that. I will try to speak slowly and clearly. I recognize that as a native English speaker, I don't always have enough sensitivity to the speed of my talking. So if I need to slow down, please tell me that. Anybody who's joining in a little bit late, please make sure that your mic is muted. And if you have a webcam on, please turn your webcam off. If you're not sure if you have a webcam on, please check that your webcam is not on. So with that, let's begin. For those of you who are newer, we'll begin at the very beginning. Ophir offers a range of measurement solutions for laser power and energy, as well as beam position and size. The appropriate sensors. We also offer standalone meter call standalone because they can work standalone. The display, you're familiar with them, I assume. They can also work connected to a PC. And we have a range of P interfaces which can only work connected to a PC. And again, I'm assuming that you're more or less familiar with the offer, with the solutions that we have available. Working connected to a PC, the PC software application that one uses to communicate with and control the various instruments is our StarLab application. StarLab, I should make clear, works those instruments that connect to a PC via USB interface. For other instruments that have RS-232 connection to the PC, one doesn't use StarLab, one uses our older StarCom application. Instruments I'm referring to are the Nova and Laser Star. The VIN and the Nova 2 also can be connected by RS-232. And again, if you're using them with RS-232, you would use StarCom as opposed to StarLab. If before we actually StarLab and get inside it, a quick round of what StarLab enables one to do. This will be a table of contents. Of course, it enables you to measure and display measure data using a variety of different graph types depending on what's most comfortable in the application. It is the use of a wide range of functions in addition to just taking a reading. It enables one to connect multiple channels, as we call it, or sensors in parallel, and not only to take measurements with multiple sensors at the same time, but also to log and perform analysis of the data from multiple sensors at the same time. One to communicate with the instrument and control it within one's own software external to StarLab. We're going to talk a little bit about that towards the end of the web. In other words, a type of a set of remote control functionality that's especially useful for systems integrators, for example. We very strongly in concept of user flexibility in all of our solutions that we offer. We see ourselves as offering tools to our customers to enable them to do their work in the most effective way possible. As far as we can, we try not to tell them how to do their work. And with all that, with all the functions that StarLab has, it remains a very easy to use software application, very intuitive, rarely needs to open up a user manual. I'm going to be showing you that now. So with that introduction out of the way, what we're going to do, the bulk of the webinar is actually going to be live with StarLab. I have some sensors set up. I have some equipment up over here. I'm now going to share my screen with you, and hopefully you can see that reasonably quickly. Now sharing my desktop with you. So to begin, StarLab icon, StarLab 2.40 is the version that's currently available. Doubles and the application opens up. The first thing we come to is the Select Devices window. We're going to start off. We're going to go step by step. We'll start off with only a single channel. We're going to select one of these sensors. The instrument to which it's connected gets selected along with that automatically. With one, it doesn't really matter whether we choose together or separated. It's only one channel. We're going to click on together, and now we're in the main measurement screen. Just have a look at what we have here, and then we'll start working with the various parts of it. First of all, here we have the numerical readout. We have the graphical display area. We're going to optimize all of these things in a moment. I should make clear already at this point that the particular functions that are shown here and the particular choices that the user needs to make depend on the sensor being used. Measuring energy per pulse with a electric sensor, there are different parameters that he would need to choose from. In this case, we're looking at a thermal sensor, the 3AP, and the functions and the choices that are brought up here are defined by the fact that it's a thermal sensor. All right, just keep that in mind. The system knows how to identify, all of our instruments know how to identify the sensor, and knowing the definitions of each sensor, the software will then bring up the relevant functions. So the thing we would want to do is go in and just make sure these are the measurement parameters. These are the same parameters that you would need to be selecting if you were using a Vega or a Nova 2. In the case of a thermal sensor, we might be measuring average power. We might be measuring single shot energy. In this case, we'll leave it at power. Or wavelength. Again, settings to choose from are defined by the sensor. And range. In this case, range. We, for example, change that to the 3 milliwatt range. I already knew what the number was anyway. We want to save those settings as a default to be stored in the sensor so that all future use of this sensor, anytime the sensor gets connected to an instrument, these are the settings that will come up automatically. We can click on Save. And configuration has now been saved in the sensor. Okay, it's the main measurement screen. can adjust the, again, with a webcam on, please turn your webcam off. It's making it a little bit difficult for me to see my own screen. Frank, if you could please be so kind and check your webcam. I think that your webcam is on, okay? We can adjust, for example, okay, we can, for example, the time frame x-axis. The x-axis in this case is time. Let's that down to about 1 minute. Down to 1 minute. The screen moves a little bit faster. We adjust the scaling of the screen. This does not have anything to do with the scaling of measurement. This is only to do with scaling of the displayed graph. Okay, this is to make it easier for us to see what we want to see. The measurement continues uninterrupted. Okay, could change the scaling either by manually moving the the sliders here, or by simply typing a number there. Okay, so that way we can play around with the graphics to make sure we're having a easily understood graphical display. The graph limits, we can adjust, of course, the units. We want to make sure that they're appropriate. Again, is independent of the fact that we chose the correct power or energy range and parameters for the measurement itself over here. Numerical readout, and that's setting the range of the measurement and setting the range and the time scale of the graphical display. We have a number of different graph types that one can choose from. What we're looking now is a line graph. I'm going to pass my hand over to the sensor, and you can see that that bonds. If we prefer, instead of a line graph, we can switch this to a bar chart. We can switch it to a histogram. An histogram, if you're not familiar with it, the x-axis is the power. The y-axis is the number of times that each given power has been measured. In this case, because our setup is not really moving, it looks kind of boring and consistent. We can change this to a pulse chart. Again, if that's relevant, here again, we're looking at the last 100 pulses, and time axis is moving. Or for those who prefer, we can work with an analog needle. And I move my hand across the sensor, the analog needle responds. If we select persistence, we can see sort of of where the analog needle has been. If that's not important to us, we can get rid of that. Let's back to the line graph. What is this statistics window? This is statistical information about what happened in this measurement from the time it began. Shown here are the minimum and maximum values that have been measured from the beginning of the measurement, what their average is, what the deviation is in that range of measurements, and shown the number of times that we have been over range if we have, so that you'll see what over range looks like. If we change this to a that I know is too low, then we now over range, and as you'll see over range, we can go to up, and it'll automatically put itself to the correct range. It takes us out to do that. Mentioned earlier, the particular configuration of what comes up, what functions or what parameters is defined by the sensor type. If we had a pyroelectric sensor here, we'll also be shown the frequency of the pulses, and we would have a few other functions available here that are relevant to pyroelectric sensor for the sake of simplicity. And because we have only 40 minutes, we're not going to go through every single one of those options. I think the idea is clear. In a previous webinar, we talked about beam track. If we were using a beam track sensor, which, as you know, measures power and energy as well as position and size, then we have, again, a few functions relevant to that. We would have the position screen, the stability screen, etc. We're going to keep things simple and just stay where we are. Just briefly before we move on to the next section, I'd like to just show you one or two things. In advanced functions menu selection, there are a few other things that we would use to optimize the measurements a little bit further. Okay, on a periodic basis, we may need to zero the instrument. That gets rid of any electrical biases from inside the equipment. Upgrade enables the user to adjust the internal calibration factors that are stored in the sensor. Must add, with all due caution that's needed when one is doing that. Response enables the user to adjust the response time of the sensor, again with all due caution that's needed when one is doing that. Frequency, depending on what country we're in, the AC mains frequency is either 50 hertz or 60 hertz. We make sure that that's on the correct setting to avoid a hum or noise getting into our system through the power supply. Info tells us what the channel or the sensor is that we're currently looking at. Instead of just taking a reading, sometimes we need to also perform some additional processing and using functions. We click on the plus sign to open up the functions view. And again, for those who are familiar with the use of our sensors with, let's say, Vega or the Nova 2, these are the same functions that you would get in the relevant part of the menu on the Vega or the Nova 2. Here just maybe looks a little bit different. So let's point out what each one of them is. If I have a particular jumpy reading, which at the moment I don't, but if I did, and it may be a little bit difficult for me to read, I can sort of smooth out the jumpiness of the reading by clicking average. Now, I can, for example, have the application show me not the instantaneous reading, but rather the running average over the past 3 seconds, and that may solve the whole problem of the jumpiness. Let's say if I'm measuring somewhat low power in a room that has background light in it, and I can't get rid of the background light, what I do is I click on offset with the laser beam blocked. And all measurements from that moment on, as long as offset is selected, will have automatically subtracted from them the backlight that was reaching the sensor when I clicked on offset. And that way I can effectively cancel out or subtract out the background light, even if I can't physically actually turn it off. Okay? Scale factor. If I to take measurements, for example, after some kind of an attenuator or a beam splitter or something like that, but what I want to display is the power before that optical component, is I know the effect that optical component having on the beam, for example, a particular level of attenuation. I would select scale factor. I would manually enter the factor that I know, for example, of 50% attenuation, whatever it might be. Click on scale factor. Then what I'll see here is not the actual power that's reaching the sensor, but the calculated power based on the average power that's measured and based on the factor that I entered. And it'll show me the calculated power before that optical component. In locations that's quite useful. dBm, in locations that need the units to be in dBm instead of in milliwatts. For example, in telecom, when using optical fibers, I have the power to be in units of dBm instead of milliwatts. Okay, nice. In many applications, I might need, for example, to measure the power that's coming out of my laser. And then I need to measure what happens to that power after a few additional optical components is set up. How much has my power gone down after this filter, after that filter, after that lens, or whatever. So when I can normalize, it measurement that was in effect when I click normalize, and it uses that as a reference, and then all further readings are shown as a ratio. Right now, since not much is happening between my light source and my sensor, the numbers all seem to be pretty close to 1.00 something, 0.9 something. If I put mine briefly in front of the sensor and block the light, you can see that now my ratio has actually gone down. Unclick normalize, it goes back to the absolute reading that was going on beforehand. And I can change the reference value. I can manually type in a reference value if necessary. The case is I need to measure not the total power that's arriving at the sensor, but I need to measure the power per square centimeter, for example, the power density or the energy density. The sensor obviously measures the power or the energy. To convert that to density, I need to know the size of the beam. I need to enter the size of the beam. That tells StarLab what that is, and then StarLab can do the calculations after that. So if I click density, it will now show me the power density in milliwatts per square centimeter, or whatever the relevant units are. I can usually change what the dimensions are. A round spot, I would enter a diameter. If it's a rectangular spot, then I have to enter two dimensions, the width and height. Okay. Not only being asked for the diameter. I add density, and it goes back to a regular reading in milliwatts. So moving right along, we've known most of what one can do, at least the main features that one can make use of when you have a single channel. In many cases, I want to record data for, let's say, offline analysis of some kind afterwards, or even simply for keeping a record. Let's put the scale back to something relevant. For that purpose, we have data logging capability. So the way we would log or record the data, very simple. I go to this icon, which is log setup, working tools. Click on that, and here's the settings screen. The default is that it comes up to log one screen of data. In this case, that means 1 minute, or seconds for some reason. And it tells me how much space is available on my hard disk so that I can sort of use that as a sort of a sanity check. If I deselect that, then two other options come up. One is to stop logging after a preset time period, and I can set how long that's going to be. Or I can stop after a given number of measurements. Select that, and just do to start log. I just press on the start button. If I need to, I can pause that in the middle. Log the progress bar, and it then tells me when the log is completed. It tells me the name of the file, and I can choose the file location that file is going to be from within that log setup. I would go into browse, and I would select where it is, where it's going to be stored. If I want to have a look at that file, there's a few ways I can do that. The quickest way is just by clicking log file location button, and I'm assuming that's the file that I recorded just now, and I open that up. The default is that it opens up as a text file. That I see the basic details, the identification of the log file, the settings that were in place. I can see the statistical information, and I see all right, this is obviously not the file that I just recorded. This is from a pre-recorded multiple channel file, but essentially, if we ignore that for a second, we see the timestamps and the actual readings for each timestamp. Okay, I can then get out of that, and I'm back in the main measurement screen. I get the log file. All right, now remember the name of the file that I just lost, so I'll open up the right one. I can open file, open. The default is opens up not as a text file, but a graphical file in the same format in which it was recorded. Of course, I can change the settings because the measurement has already been done, but I get the statistical data. I can adjust the scales if I want to look at the graph differently. If I need to zoom in, click and drag, left and drag, and I can zoom into an area of interest. If I just left click and drag anywhere in the reverse direction, it takes me back to the original file. I do that by Xing out that, not this, that'll close down the application, but that. Now again, I'm back in the main measurement screen. If I can also open text file as a text file. Another very useful capability of StarLab is that if I click on Open File as text, but instead of double-clicking on the file, I right-click on it. I have two other options. I'm not going to them now, but one of them is that I can open it with Excel, so I can convert this into an Excel file and carry whatever analyses and calculations are made possible by Excel. I can export it to a bitmap. There's a very wide range of things I can do with the data. And basically, again, a tool for the user to use according to his application requires of him. Another thing I can do is I can add a note to a logged file. I can record experiment number 7, record on the 15th of September, etc., anything like that. And one last feat I'd like to show you at this point about logging is I can also take files from an instrument. Now I'm not connected to an instrument. If I were connected, for example, to a Vega, the icon would be active, and then I can upload a recorded file from the instrument and then display it here on StarLab and open it up and then do whatever type of analysis I need to do using that. So I'm not only limited to files that are recorded right now here, I can upload from the instrument. These alone instruments that I referred to earlier have the capability for onboard logging. For instruments do not have onboard logging, and our PC interfaces obviously don't have onboard logging capabilities because they, by definition, work only when they're connected to the PC anyway. Okay, we're going to move on to the next part now, and we're going to move on to multiple channels. So we're going to close our lab, open it up, and this we're going to select multiple channels. So we're back to Select Devices window. This time we're going to select in channels. If we click the box up here in the corner, it automatically selects everything here. I could also have just selected the pulsar. In this case, I have only one instrument, so selecting that one instrument will obviously include both sensors that are connected to that one instrument in this case. And again, we're going to choose together. If we should just point out, if I select separated, the various channels open up in separate graphs that are not related to each other, and I would manipulate each one individually. We're going to choose together so that they're all actually on the same axis, and maybe what we can do with those soon. So first of all, we're back in our main screen. Now we see two channels. Here's the thermal sensor that we had before, and now in addition, we also have a photodiode-based sensor. We could have had a pyroelectric sensor, whatever we can connect quite a number of channels in parallel. One is selected is the one, both of them show up on the graph, so each one is represented by a different color. We can see here that the B300 is represented by the blue line, and the active channel, so that one is bold. The third one is represented by the red line, burgundy, whatever you call that color. And it's also here, but it's not bold. If I select that one instead, it becomes bold. I have additional channels. Each one will have a different color. Okay. If I can delete one of the channels if I need to just focus on that channel for the moment. Purposes right now, we're going to keep them both active. Axis is common to both of them. We're going to bring that down to 1 minute just so that things move a little bit faster. It's a little bit more effective. We mentioned each sensor is represented by a different color. If I wish, I can split this into two separate graphs. The axis is common, but the graphs are separated. There may be times when I need to do that. I can now, for example, if I want to display this channel using an analog needle and this one as a line graph, I have that level of control. And first, if I wish, I have the level of control. I cannot remerge them unless I turn them both back into the same type of graph. I come now back in a bad line graph, and we see both channels opposite each other. The statistics and the ring refer to the active channel. Change the channel. You can see these have again both adjusted themselves. Functions, again, I would choose the appropriate wavelength and range. In the case of a PD300, I mentioned earlier that the user needs to make are those relevant to that sensor. In the case of a photodiode sensor, one of the things that the user needs to let StarLab know is the external filter in or out. Okay, it's not something that the user is asked when using a thermal sensor because it's not relative. To illustrate what I said before. Again, if we make any changes, we could save them if we want, or we could not save them. Now, one powerful features that are available here when using multiple channels is what we call the math channel. In applications when using multiple sensors, let's say, for example, I have an optical system, I have a laser beam traveling along, some kind of going through various optical components. There's mirrors, lenses, beam splitters, and I want to simultaneously measure the power at each point and compare them. So I'm able to, for example, I might want to see on a separate channel, because this is information that might be important to my application. I want to know what the ratio between the readings being measured by these two sensors. So add math channel. The dimension that comes up is the ratio of A over B. That is now a third channel represented by the green line, and that's this one over here. Okay, of course, unitless because it's a ratio. Then if I need to log my channels, I actually log that. We click set up. Then after just a number of readings, it goes a little bit faster. And start the logs. Regress bar. Complete. Let's have that. It's going to open up now. Okay. I set up now as a text file. Here are all the details: channel A, channel B, and channel M, the math channel. I've got the parameters of the measurement, the statistical data. Now here I have at each stamp the value of A, the value of channel B, and the value of channel M, the math channel. And duration of the measurement. If I want to, I'm not going to do that now. I could again open it up as a graphical display, and I'll see the three channels graphically, pretty much exactly as we see them here. Pass my hand over the sensor, then you can see what happened to channel A, what happened to channel B, and what happened to the ratio between them. Change the function. I can change the function. There are a few default functions available. And one of the nice things here, this is actually quite cool, I can define my own function. I'm going to show A plus B divided by A, B. I don't know if that has any meaning whatsoever, but here for whatever that's worth. And I can log that, I can display that, I can do any kind of analysis, I can export that to an Excel file or a bitmap, etc., etc. If I want to get rid of it, I just X out and I go back to the regular two channels that were active to begin with. If I want to preferences, and if I were to select open last configuration before shutting down, then next I turn back up again. In fact, I shut down StarLab. If I click on StarLab and open it up again, it doesn't stop at the select devices window. It goes right back to the configuration that it was at before. So the particular way of doing work that I use all the time, I would click that, and I don't have to start setting everything up from scratch every time I sit down to my desk and begin working. Okay. There's obviously a lot more that we can do, but I think we covered the main features. Before I shut this down, I should probably just show you what other things are available here quickly through the quick select icons. This would take me back to the select devices window. This would restart and restart the application. This would display without affecting any devices. By the way, I didn't mention earlier, I am cheating a little bit. I have my colleague Yitzhak here with me so that if I get asked questions that I don't know the answers to, I have an expert here who can whisper the answer in my ear. So what he just whispered in my ear is that this does not restart the application. I'm sorry, I stand corrected. This restarts the devices. Okay, or may not have impact on the measurement depending on what you're trying to do. This clears the display without affecting the measurement or the logging that's going on. If I'm using a pulsar, a pyroelectric sensor, the pulsar has the capability to detect missing pulses. These would then become active and allow me to set up parameters to enable detection of missing pulses. Okay, we're now going to close StarLab and stop sharing the desktop and wrap this up. Last thing that I want to mention, and we're not demonstrating this, I mentioned it very, very briefly at the beginning. I'm just going to mention it again briefly now. We talked about the capability to have control, communicate with and control from within one's own external software application. For systems integrators, for example, that use of Ophir's COM object, which is strictly speaking not part of the StarLab software, but it's there in the package. And when you install StarLab, that function is there. We're not going to discuss it in any level of detail now. It's not something that I can really demonstrate now in the webinar, but it's there. There's information on it. Examples are provided to get users started. Who makes of this particular function. There's quite a bit of information, including the relevant documentation, on our website on the StarLab page. There's a section there on the COM object, or for legacy systems and ActiveX control that was there before we introduced the COM object. If you follow the link there, it'll take you to a link that you can click on to open up detailed documentation. If anybody has any questions on that, of course, please get in touch with us. So, as I mentioned at the beginning, just to give a quick but reasonably thorough course, I guess we'll call it, in the capability and the use of the StarLab application. I hope we accomplished that. StarLab is a very powerful and nevertheless easy to use tool, easy to learn. I hope that I demonstrated that to you. I'd also like to just draw your attention to a video that we have. It's a YouTube video that's of course, it's on our website. There's a video section there. It's about 8 minutes long, where Ephraim also walks you through pretty much everything that we saw now. Very nice, very clear, useful, quick refresher for those who want it. You can, by all means, encourage your customers to have a look at that as well. In 8 minutes, it can more bring them up to speed so that they can sit down and start working. So do have a look at that. Having said everything else that we said in the last 39 minutes, the best way to learn how to use StarLab is to use Lab. I very warmly encourage you to find some time or make some time and just sit down and work with it a little bit as you saw. I hope it doesn't take a whole lot of time to learn how to use the application. If you obviously have questions, you can ask now or at any time. If you have any further questions, you have a few more seconds in which to ask them. I'm actually 5 minutes below the time limit that I said it would take, so that's good. All right, I see there are no questions. I thank you very much for being with us. I hope this was helpful. Again, feel free to contact us online, offline, if you have any questions. That's all for today. Have a very nice day, and thank you again for joining us.